Hi, once again with a new video. I'm Viraj and this is my YouTube channel, Maths by Viraj. In previous two videos, I did sums from question numbers 1 to 10 in paper 2019 May 1ish. Today I'll be doing question numbers from 11 to 15. So stay tuned. Remember, subscribe Maths by Viraj and click on the bell icon so that you will be notified as soon as I upload a video. Children, while I'm explaining sums, you might see a link over here. What I'm going to do is the tips or the easy methods of doing particular sums. I will upload those videos separately and I will send the links over here. So make sure if you do not understand the sum clearly, you can always go to the link over here and check it out. The tips. Children, question number 11 asks us to find the value of C to its upper bound. Children, as you can see in the 11th question, A is equal to 6 and it is connected to the nearest integer, and B is equal to 15 where it is connected to the nearest 5. So there are two values that you should find: the upper bound and the lower bound. Therefore, in 6, that is in A, it is connected to the nearest integer. What is an integer? Integer is a whole number. Assume the smallest integer to be 1. So if I divide 1 by 2, answer is 0.5. So the upper bound and the lower bound can be as 6 plus 0.5 being the upper bound and 6 minus 0.5 being the lower bound. Therefore, the upper bound value is 6.5 and the lower bound value is 5.5. And this is for A. Children, if we consider the upper bound and lower bound for B, it would look like, because now B is for the nearest 5. Therefore, we divide 5 by 2, which gives us 2.5. Therefore, the upper bound of B will be 15 plus 2.5, 15 minus 2.5, which gives us the answer of the upper bound of B as 17.5 and the lower bound of B as 12.5. As you can see on the board, for A and B, we have found the upper bound and the lower bound. For A, the upper bound is 6.5, lower bound is 5.5. For B, the upper bound is 7.5 and the lower bound is 12.5. Now the question being asked is, calculate the upper bound for C. The sum is C equals B minus A. So to get the upper bound of C, you should subtract the smallest possible value of A from the largest possible value of B. Therefore, what we do is C is equal to the upper bound of B, that is 7.5. From that we subtract the smallest possible value of A, which is 5.5. And the answer and the upper bound answer of C is 12. Again, make sure to get the upper bound value of C, the largest of B should be subtracted by the smallest of A, which is 17.5. The largest of B and the smallest of A, which is 5.5. Therefore, 17.5 minus 5.5, the answer is 12. Children, question number 12, part A is normal factorization. Part B is a sum where we should find the value of the variable m. And part C, we should find the value of B in the form of a fraction where y and b are given in the form of an index number. Children, this factorizing, I will do the sum and the explanation and the deep explanation of this factorizing method you will be able to see from the link over here. Right. Now children, when we have such an expression, we multiply these two numbers 2 and 6 so that we get the answer 12. We should find two numbers that multiplied form plus 12, and when those two particular numbers are added, we should get the answer minus 7. For instance, 3 times 4 is plus 12, but 3 plus 4 is plus 7. In this case, we need it to be minus 7. Therefore, this is wrong. Let's try minus 3 into minus 4. Minus 3 into minus 4, the answer is plus 12. And minus 3 plus minus 4 is minus 7. Therefore, the two possible numbers that I could write instead of minus 7 are 2x squared minus 3x minus 4x plus 6. Now, for the ease of doing the sum, I can divide the sum in the middle. Now, previously, as I have taught you all in lessons of algebra, take the common terms out. Here you can clearly see that the common term is x. Therefore, it is 2x minus 3. Children, you should understand, in this side, you should find a factor which is equivalent to 2x minus 3. Therefore, I can take the common term minus 2 out here, which gives me the answer 2x minus 3. The two possible factors of this are 2x minus 3 and x minus 2. Please do understand the fact that I took minus 2 out so that these two factors 2x minus 3 are common on either side. Because when I re-multiply 2x minus 3 by the term minus 2, I should be getting this particular term. Therefore, the final answer of the expression 2x squared minus 7x plus 6, when factorized, you get 2x minus 3 and x minus 2. Right, children? Question number 12, part B. Now we are supposed to find the value of m. We know that when division goes to the other side of the equation, it is considered as multiplication. Therefore, 4m plus 9 is 3 times 7 minus 2m. The whole expression 7 minus 2m is multiplied by 3. Division, the number 3 is divided here. So when it goes to the other side, it becomes multiplication. 4m plus 9 is 21 minus 6m. So we take all the m terms to one side and the other terms to the other side. 4m plus 6m plus 9 is 21. 10m is 21 minus 9. Therefore, 10m is equal to 12. M is equal to 12 divided by 10. We can leave the answer as 1.2 or in the form of a fraction, which is 1 and 1 over 5. Here please understand the fact that 10 and m, they are multiplied. Therefore, when 10 goes to the other side, it becomes division. Very easy. 4m plus 9 whole thing divided by 3, which is equal to 7 minus 2. When you do the math, the value of m is 1.2 as a decimal or 1 and 1.5 as a fraction. Children, when you look at question number part C of question number 12, this is very easy. When you see such a number, you can write this as y to the power 1 over 4. We do remember this in the form, if we get cube root of y, we write it as y to the power 1/3. Similarly, instead of 3, if we have 1, you can write it as y to the power 1 over 4. Therefore, y to the power 1 over 4 is divided by y to the power 1. If the bases are same and if it is division, what can we do? We subtract the powers. which is y to the power minus 3 over 4, which is y to the power minus 3 over 4. Therefore, the answer of B is minus 3 over 4. Simple as that. Children, question number 13 is a question about probability, and first you have to complete the tree diagram and then answer the questions where the part B is to find the probability where there are two boys in the team. And question number C, it's a bit of a lengthy question. They have asked, after the first team has been picked, a second team is picked. One child is picked at random from the child left in group C, and one child is picked at random from the children left in group D. Work out the probability that there are two boys in each of the two teams. Let's try to do the calculation. Children, there are two groups, group C and group D, in question number 13. In group C, there are 6 girls and 8 boys. Therefore, in group C, we know that the total number of children are 14. What is the probability of finding a girl? Out of the 14 children, the probability of finding a girl is 6. Therefore, it is 6 out of 14. Therefore, the probability of finding a boy is 8 upon 14. We write it as a fraction. And the few basic tips for this particular sum, you can go to the link over here and see them. Then in group D, there are 3 girls and 7 boys. Therefore, the total number of children in group D are 10. Therefore, finding a girl is 3 over 10 and a boy is 7 over 10. Very easy. 3 over 10 and 7 over 10. Fine. Part B, they have asked, work out the probability that there are 2 boys in the team. So, 2 boys in the team, we have to follow this path. Why? We assume. So, the probability is some kind of an assumption. We consider all the possibilities of a certain event happening. Therefore, we pick a boy from group C and a boy from group D. So, a boy in group C is 8 upon 14 and a boy in group D is 7 over 10. Therefore, the probability that we get is the answer that we get is 2 over 5. That is, we multiply 8 over 14 and 7 over 10 so that we get the answer of 2 upon 5. The probability of getting 2 boys in the team from group C and group D, 8 over 14 into 7 over 10, which is 2 over 5. Children, part C, after the first team has been picked, a second team is picked. One child is picked at random from the children left in group C. So, children left in group C, and one child is picked at random from the children left in group D. Fine. Work out the probability that there are 2 boys in each of the 2 teams. So, in the previous sum, that is calculating to find the probability of 2 boys, part B, we came up with the answer as 2 upon 5. In this case, now since one boy has been picked from group C, what is the probability of finding a boy in group C? Now one boy has already been picked. Therefore, it is 7. So the total number of children goes down to 13. Similarly, here one boy has been already picked. Because in this calculation, we know that we picked one boy. Therefore, the total number of boys goes down to 6. And the total number of children, it goes down to 9. Children, these are assumptions that we have taken, right? Therefore, what is the probability of getting 2 boys in each of the 2 terms? Very simple. Again, we should go along this path. 7 over 13 is to be multiplied by 6 over 9. And this has to be multiplied by the previous answer that we got, 2 upon 5. And the answer that we get is 28 over 195. Again, let's try to understand what this sum is. First, we calculated the probability of getting 2 boys from group C and group D. Therefore, originally we had 8 boys and the total number of children was 14 in group C, and in group D the total number of boys is 7 and the total number of children 10. Since we have picked 2 boys from each respective group, now we have a total number of children of 13 in group C and total number of boys as 7, and in group D we have total number of children to be 9 and total number of boys to be 6. Therefore, the calculation of getting the probability of 2 boys in group C and in group D twice will be 7 over 13 into 6 over 9 multiplied, and this particular answer is again multiplied by the previous answer that we got, giving us the answer 28 over 195. Children, question number 14, it's about sets. The details are being given within the curly brackets of A and B. The first question, we are supposed to find the common terms of A and B given as A intersection B. And part B, we are supposed to find the list of members of the possible set in set C. Right, children, in question number 14, it is given that our universe is, we consider all the positive integers less than 20. So we consider numbers from 1 to 19 but not 20. A, it is given as x is smaller than 12. So we consider values of numbers which are less than 12, which is 1 to 11. B, it is given as a range, x is greater than or equal to 7 and less than 16. Therefore, the possible numbers are from 7 to 15. Here the first question they have asked, A intersection B. So what are the common terms or the common numbers that are in set A and in set B? So it's pretty easy. 7, 8, 9, 10, 11. Therefore, the common elements of set A and set B are 7, 8, 9, 10 and 11. So the answer for part A intersection B, the answer is 7, 8, 9, 10 and 11. Right, children. Part B, C is a subset of A. They are given C is a subset of A. That is, whatever the values that are in C, you already find them in set A. And they have given that NC is 3. That is, the total number of elements in set C is 3. Also, they have said that given that all members of C are even numbers. Right, all members of C are even numbers. Therefore, we just have to select all the even numbers in set A. And they have given that the total number of elements in set C are 3. Therefore, set C, you can come up with various answers. You can come up with 2, 4, 6, which is correct. And also you can come up with the answer 6, 8, 10. Any set of numbers where the numbers are even numbers and they fall under set A, they belong to set C. Make sure only 3 numbers are, because the total number of elements in set C is 3. Children, question number 15. It's about a recurring decimal, and we are supposed to write it in a form of fractions. Children, the tips or the easy methods of such calculations, you can go to the link over here and see them. Right. Now children, you see that 0.254. This is a recurring decimal. If I am to write this in form of a decimal number, it would look like 0.2545454 keeps on repeating. Only two numbers that repeat are 5 and 4. So I can assume, let's assume 0.254, this whole number to be x. If I multiply this by 10, if I multiply whole of this equation, let this be my equation number 1. If I multiply equation number 1 by 10, the answer that I would get is 10x is equal to 2.54, which are recurring. Fine. Let this be my equation number 2. Now children, my objective is to get rid of the numbers which are recurring. So to get rid of the number which is there just before the numbers start recur is 2. So I multiply whole equation 1 by 10, which I get the answer as 10x is 2.54, which are recurring. Now I will grab all of these, that is 2, 5 and 4. That is, I multiply the whole expression 0.254, which we are finding for recurring, by 1000, so that all the numbers are being considered. Let's see, I multiply equation number 1 by 1000, where I will get it as 1000x is equal to 254.54, which are recurring. Let this be my equation number 3. Now, children, this 2.54 which are recurring can be written as 2.545454. Sorry, 2.545454. Right? Now this, when I multiply whole of this equation, first equation, by 1000, I get it as 254.545454, which this can be written as 2.54 recurring, and here 254.54 which are recurring. Now I am going to subtract equation number 2 from equation number 3, where I get the answer as 1000x minus 10x is 254.54 recurring minus 2.54 recurring, which gives me the answer 990x is equal to 252, and x is equal to 252 divided by 990, which gives me the answer 14/55. Very easy. Hope you understood today's questions which I discussed with you all. Please make sure that you go to the link over here and see the tips for the questions. Make sure you subscribe and click on the bell icon so that you will be notified as soon as I upload a new video. Stay tuned and subscribe. Maths by Viraj.